In this example, we have three functions in a, b, and c, and in each case, we want to determine whether the function is odd, even, both odd and even, or possibly neither odd nor even. And so just recall these, how we check these conditions for even and odd in general. We say that a function is even if for all x in its domain, when we evaluate f at minus x, we get the same thing as when we evaluate f at x. We say a function is odd if for all x in the domain, when we evaluate f at minus x, we get the same thing as when we evaluate f at x and then multiply by minus 1. So f of minus x equals minus f of x. So let's check those conditions. And just to use some information that we saw in a previous video, we graphed the function f of x equals x squared minus 6, and we had the graph above. And notice that this graph is symmetric about the y-axis. Okay, meaning for each point on the graph, such as minus 3, 3, its reflection across the y-axis at 3, 3 is on the graph, and that holds for all of these other points on the graph. So checking for even, what we do is we evaluate f at minus x. And so in this case, we plug in minus x in place of x in the formula, and squaring minus x gives me x squared minus 6. And remember, f of x was x squared minus 6. So since these two are equal to each other, we see that f of x is even. Checking to see whether the function is odd, we again would need to compare what we get when we evaluate f at minus x. And recall that we did already. And now I would compare that to what I get when I take the expression for f, which is x squared minus 6, and multiply that by minus 1. And in this case, I would get minus x squared plus 6 when I distribute that negative side to both terms. And since these two expressions here are not the same, then we would say f of x is not odd. Okay, so this part A, the function f was even, since f of minus x and f of x give me the same thing, but it is not odd. And so one observation that we can make, which holds in general, is that if a function is even, then the graph is going to be symmetric about the y-axis. And we could similarly show that if the condition for a function being odd holds, then in that case the graph is going to be symmetric over the origin, about the origin. When I plug in minus x, I get minus y back. So if we had the graphs, we can just check these things visually. In part B, I don't know what the graph of this function looks like. It's not very obvious to me maybe what it would look like. So let's check these conditions using the formula, since that we do have. So to check whether g is even, we have g of x that was given to us as 1 over x cubed plus x. And evaluating g at minus x, I would get 1 over minus x cubed plus minus x. And so therefore g of minus x is equal to 1 over minus x cubed minus x. Okay, and here that's because when I take minus x times minus x times minus x, I get minus x cubed. We have 3 negatives for that one. So here, these are not equal. Which means this function is not even. To check whether the function is odd, I would compare g of minus x, which we had above, as 1 over minus x cubed minus x, with minus g of x. And so here, g of x was 1 over x cubed plus x. And now I have a minus sign. I'm multiplying this by minus 1. And so if I distribute this negative sign, instead of to the numerator, into the denominator, then I multiply every term in the denominator by minus 1. So minus g of x, notice, gives me the same thing as when I evaluated g at minus x. So since these are equal to each other, here is a case where g of x is odd. Okay, so g was not even, but it was odd. And finally, coming to part C, to check whether this function is even, I'm going to evaluate h at minus x, and that gives me 4 times minus x to the 4th minus 2 times minus x cubed plus minus x squared. So I get minus x to the 4th power is a positive x to the 4th power, and the middle term, I do get a change in sign because the power is odd. And for the last term, minus x squared gives me positive x squared. So here's h of minus x, and h of x was 4x to the 4th minus 2x cubed plus x squared. These are not the same. So h of x is not equal to h of minus x. So this is not even. And to determine whether the function is odd, I want to look at what I get when I take h of x and multiply by minus 1. So that would be 4x to the 4th minus 2x cubed plus x squared. Multiplying each term in this expression by minus 1 gives me minus 4x to the 4th plus 2x cubed minus x squared. And recall in the previous calculation to see whether it was even, h of minus x was 4x to the 4th plus 2x to the 3rd power plus x squared. So comparing these two, we see that h of minus x is not equal to minus h of x. So therefore, h is not odd. So h is neither even nor odd.